Hello everybody, it's Mike Levin on April 3rd, 2021. That is a Saturday. And I'm on my way to pick up some dinner. Sushi again. This is my sushi drive. I think I've done videos on my sushi drive before. And for some reason, it's a stimulating time to think about my work. And the work I've already done is to create a very simple table with a create table if not exists in SQLite. It's interesting that that syntax exists, so you can attempt to create a table every time, but if it exists, it won't happen. The create table command won't get carried out, but it's always there as a useful reminder to you that exactly what the table looks like, because when you look at the code on your do it every time loop, you're reminded of what the table structure is. You see this command that was used to create it in the first place. So there's a lot of transparency to this current approach I'm taking. It's now that we've collected lots of data from, usually HTTP, basically web-based services and scraping and various sources of data, we've made a request which has required a few arguments to provide on parameters that are part of the request, and the response that comes back is potentially multiple responses bundled into one package, multiple rows of that response type. So we were asking of Google Search Console URLs. Tell me all URLs that had activity for this site for this date range. Usually start and end date being the same day, and we go day by day for all days provided. And it's a nice way to avoid aggregate data. You're actually asking for things on a daily basis, which you're probably going to get some ready-made counter for. So things are going to be pretty quick to query, and your resolution is going to be pretty good. Your precision of your data, it's not going to be averaged or aggregated or prioritized down. And when you ask for certain date ranges, the calculations have to be done server-side before the request is sent, and that can be a fair amount of processing you're asking for that server to prepare that response for you. So sometimes it cuts corners, and that takes the form of reduced precision or accuracy in the numbers that come back. So with certain APIs, Google Search Console being one of them, if you ask for your data on your dimension, like URL or page, really, they call it, on a day-by-day basis, then very little of that averaging and loss of precision takes place. You get the best numbers. That's why I made this application, this part of SEO/ML that empties out your Search Console data, day range based. It makes sense. And so in the raw data that came back, there are people who are just not proceeding at the light here. They're talking to each other, and even though the lights are in green, they were staying there, and now we're back to normal, except he's slowing down to extreme slows in front of me. I will not force him to make me tailgate him, so I'll slow down even more. Thwarted. So, anyhow, coding projects in Google Search Console. And now we have some data, and we can do things with it. And one of the things I can do with it is create new row and column, new traditional SQL row and column tables, and insert the data from the raw data collect into those SQLite row and column formats, and then be able to do much more traditional SQLite queries and hook ready-made tools to the data, because everything hooks to row and column SQLite data. It's an easy data format to import into other things and to visualize and to do further transforms and data studies with. So this raw data format, where you just sort of plopped it down in key value pairs, is very easy through the use of generally list comprehensions, because a list comprehension can refer to every JavaScript object, because it looks like a JSON object, for every object across these key value pairs. So for every value in this database, grab this location in the object. If it exists, you can just put it in a try. So in those places where the object shape doesn't match, it'll just breeze over it. And on those places where it does match, it'll grab a value, which will be part of the returned array for the list comprehension. So you can use list comprehensions quite nicely to refer to, say all the rows for the rows key on the following, set of objects found in the keys in this SQLite database. And so I'm doing in my current project, and in that way, you can get all the URLs of the site, and you get a single list of URLs. And if you use list comprehensions to turn it into a set, you've naturally deduped it, and then you're sitting on top of something which you can use as the initial data in a new table you create with SQLite. And URL data is interesting because the U of URL is unique constraints. It's suspiciously suitable as a key for a database. So since you've ensured the uniqueness of your data, because it is a URL, by definition it's unique. You won't have two of the same URLs in this table, or else it would be duplicate. So what a perfect primary key to use. So you don't need the row IDs, the automatically added index that SQLite creates. So when you create the table, you can turn off row ID. You can do other things like turn off the ability for the primary key column to support nulls, and set the URL column, the one and only column in the table, to be the primary key, to not support nulls. And then you have something even simpler than the key value databases that were being simulated earlier with SQLite. You have a truly one-column table. It's like Excel with one column, only column A. And that column is called URL. And in a primary key sense, in a database sense, it is the primary key, a text-based primary key field that does not support null. So something must go in, and that something cannot exactly match any of the other somethings that are also in other records for that one and only field. That is the perfect URL table. And it used to be that SQLite didn't support that sort of thing. It would still add a row ID for automatic auto-incrementing primary key. However, you can turn that off. You can, override the default when you create the table and choose any column you want as the primary key. And that will say it has to be unique. That's the definition of a primary key. Not support null, so you don't have the one exception where it doesn't repeat with any other keys, but it still contains no value or contains null value. you turn off that possibility, and now you have something which is extremely suitable for just a list of URLs. Perfect native SQLite table structure. Been there, done that. That's code that I'll work into my next video. However, the one that's of potentially more interest is the non-minimalistic approach, the one where you capture all resolution and data points that is represented in your raw data. You're just turning it from JSON-ish format to pure row and column format. And I'm not going for a high degree of normalization. I'm not going to, deconstruct my data into different tables. I'm generally going to just flatten the JSON objects. So if there's one-to-one, relationships, that means you can just make them all a field in a database, key value pairs. We could even reintroduce the concept of named tuples here, the way I did it earlier for collecting the raw data. But I think that that's going overboard a little bit. Once you have stuff staged for a transform for every key in the raw collected database, in the raw data that you've collected, apply this list comprehension to make this particular cell in a row. So for each field of your record, cell in a row, choose your terminology. For each field in your record, that seems to be a more universal terminology. Pull up the JSON value, which is really a Python value, because even though it looks like JSON, it's now a native Python object, really. So you can then reach directly into it and start using subkeys, saying if a rows subkey exists, then grab the rows, and then you're going to have a list-like object to iterate through. And as you do that, there's going to be metrics for each one. There's going to be the number of impressions, the number of clicks, and the average position you are in for that time period. So I guess what we do as we step through this loop depends on what we want our actual outcome result data to be. What is keeping full resolution? The temptation is naturally to create aggregate values to calculate certain minimums, certain maximums, certain averages or means for a given URL. However, what we probably want to do is reconstruct record for record what we encounter in our JSON object. So if we encounter a JSON object on the left side, we create a row on the right side through just a series of list comprehensions that plugs in each cell in the row. And that's pretty much it. I mean, there's not a lot more to it than that. While you're doing that, you probably are firing off the insert statements to plug the data into a freshly created table. So there is the creation of the table code. And we're not using an ORM. I'm going to advocate for my next few videos just understanding the SQL implementation of SQLite, the serverless embedded SQL of Python and many other environments. It's worth being able to talk to natively in its native SQL. If you're tired, if you've got SQL vendor implementation fatigue, if you've switched from SQL Server to MySQL to Postgres, much like has been my path, and have SQL dialect fatigue, and you thought pandas was the cure to your woes, never look at SQL again. Use a slightly different more Pythonic API and do lots of the same things and give up SQL, well, surprise, that doesn't always work out as planned, because dealing with native, say, pickled data frames or CSVs that you keep loading and saving as CSVs, it's not as nice as a, quote, real database there that you can talk SQL to. SQL exists for a reason. Its massive popularity would not be driven so far with that. It's not like browsers only embed JavaScript, so you must use JavaScript. That's why JavaScript's so popular. With SQL, you can choose other database environments or languages or whatever, but SQL keeps reemerging as the skill to know, the keyword for your resume, because so many things have a SQL implementation and it works perfectly well, and so many deployed things are using it, and so many people know how to write it, and low-level barrier for entry for running select queries. And I guess I could go on, but after actually doing SQL stuff for a while, for an employer or two, you realize your skills do not travel with you quite so cleanly from employer to employer as you might wish with something like a language. The SQL, is uniquely tied to the implementation of where you're using it, the table structures, the vendor dialect of SQL, the custom stored procedures and functions you have, and optimizations that have been made. And so I don't like that. I had that before. HitTail was much like that. And other products I've made for employers that I've had to support forever forward have been like that. And I don't like the whole support forever forward thing. I like, you got some scripts, you run some scripts, you put them on a scheduler, you created those scripts cleverly, sort of felt them out in an exploratory coding environment, that is Jupyter Notebooks, you documented it, you cleaned it up, you turned it into a package, you can now, git clone it into any of your servers you maintain, schedule it under systemd maintained, usually Python-based scheduler, and you're golden. That'll last you for as long as that thing needs to run. But these are only intended to run for so long. They've got a lifespan. You turn them on at some point, and they become, overwhelmed by events, no longer relevant the way they once were, and either you deliberately turn them off explicitly, or they get turned off, and the next time some servers are retired that no one remembers the purpose for anymore, and it doesn't matter because the person who asked for them isn't working for the company anymore, or something like that. So these things that get turned off, on their own accord through attrition over time. And in the meantime, you're leaving a trail of high value. You're investing yourself in the newest and the latest and the greatest for your stakeholder of the days, and you're making them happy. And so that's a way of working. It's a great way of working. It's not particularly web development, but it's very enjoyable, and it has to do with honing your skills and becoming more expertise over time at things, and internalizing stuff as tools kind of in your mind in a way that are difficult to imagine yourself internalizing, because things change so quick in technology that in the past you would not have been able to internalize this stuff. You would have had to retrain yourself every 5 to 10 years, 2 to 5 years, and depending on what you're in, if it's the latest JavaScript frameworks, for example, you are on the hamster wheel. So getting rid of the hamster wheel is really a matter of Linux, Python, Vim, and Git, and sometimes VS Code, depending on how hardcore you want to go. So it's proving out quite successful. I'm enjoying it. I did the key value pair data collections, and I'm doing a increasing amount of transforms that clean that up into its row and column. And so I guess the last concept there is that the transform that is not minimal, that is not conservative, just using a URL primary key column, what is it going to be? Well, it's probably going to be a compounds primary key with the columns that define the uniqueness. We're not going to insert name tuples into the process. It seems a little excessive at this point, but we will in fact be creating a table whose columns are its keys. It has no other reason to exist, particularly than to, have the keys, the values that go in for the columns. And those would be a single date column, which the surprise in MySQL, surprise, there is no date time data type. It's got to be integer, float, text, or a blob, I believe it is. It's those four. There might be a fifth. But SQL, there's a special type which is a auto-incrementing, although auto-incrementing, whether it's turned on, is a separate thing that has to do with maintaining data in sequential integrity and non-duplication of your keys. But by default, this row-dex or row ID is always added in the background as a default primary key. You can turn it off. Wow, such echoes of stuff I've done in the past that made it similar presumptions until I learned better. You define your key for your table as the columns that define your uniqueness, which, as I was saying, was date, of course, URL, and then the metrics that are there. There's going to be impressions and clicks and average position. And you don't have to do any aggregate because it's on a per day basis. So the whole key here actually goes, because you need all this to have uniqueness. To have uniqueness, I guess it's really only URL and day, and then the values that come out are the metrics. They don't have to be part of the key. So things like impression, clicks, and average position, we just have as 3 additional columns to the, in total, 5-column table, 2 of which become part of the key, URL and date. So a date plus a URL makes the primary key of the table that doesn't lose any resolution from this transform. It'll contain all the same data as the JSON chunky shaped source data, which is, as you'll remember, has chunks of this data in these single keys that are put in, because Google Search Console can return up to 5,000 rows at a time. So what we're really doing here is parsing through those rows, getting the days, the URL for each URL for each day out of there, and through list comprehensions over into row and column format symmetrically from left to right. Pretty easy transform. So that's my next project. That's what I'll be doing. Thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.